Welcome to part 2 of 5.1.2. We're going to take a look at this problem next, problem 511C. In the book, it showed it as 2x parentheses times x plus 5. We can also think of them as your separate factors, 2x and x plus 5. Now, once again, I'm going to try to find the areas. And I know that x times x is an x squared. X times x is also x squared. X times 1s will be x's. And so I get a result that I want you to think about for a moment. If I have 2x times x plus 5, I'm going to get 2x squareds plus 10x. Look at these numbers right here, 2x and x. What do you think 2x times x is going to be? 2x squared. What's 2x times 5? 10x. Or in other words, I have 2 of these sections. Okay, I want to do a complicated one, really trying to get a lot done in this video. And so here is the next one. This is I, or is it H? It's F. So I had them all wrong. 2x plus 5 times x plus y plus 2. 2x plus 5 times an x plus a y plus a 2. I hope I can get these tiles out fast enough. Okay, x times x, x squared. X times x, x squared. X times y, well, that's going to have to be that way because it's an xy. There's an xy. On this side, I'm going to have x times 1s, which are x's. On this side, I'm also going to have x times 1s. See, 5 of those. And then here, at y's times 1, or each y times a 1, so okay, and then in this other corner, I'm going to use some longer strips if I've got them. Those are just ones that are attached together, but if 1 times 1, 1 times 1, 1 times 5 is 5, 1 times 5, so those will fit right there. And I get my result. Lots of things going on here, but let's just make it easy. 2x squareds plus 2xy's plus 9x's plus 5y's plus 10 1's. Okay, and so that's what I had in that area. Now, in the book, that was kind of some of those harder problems that they did. Then they asked us to focus on a rule, okay? And I wanted to look with you because they gave some new problems. And this is problem 13 where they said something, for example, like in D, 5-13D, they gave us 7y times 10x plus 11y. Well, there's going to be way too many tiles there to even think about doing this on a tile mat. Just to kind of think of what it would look like. On this side, I would have 7y's. And I don't even have enough room to put it here. So I'd have 7y's going this way. On this direction, I'd have 10x's and then 11y's. And so I can tell I'm going to have a huge number. The shortcut that we hope that you see is called the distributive property. If I multiply the number times the number, 7 times 10, I will get the new number part, which is 70. Then if I take the letter times the letter, I will get y times x, or in this case that makes xy, plus, now I'm going to do the next one, 7 times 11, and y times y. Y times y is y squared. I will get my answer in a lot shorter without having to do all the tiles. The tiles are great at helping you see how things are getting multiplied. And making keeping from making some mistakes that we see common. Like one of the common mistakes is to say 7y times 11y is 77y. But we forget that when we have that y going this way, and we have a y going this way, it's going to make a y, it's going to need a y squared tile. Now, so kind of our rule or idea on the distributive property is that if I've got something on the outside of my parentheses, that I multiply it times everything in the parentheses. And to make life a little easier, you multiply the numeric parts, the number parts times each other, and then the variable parts times each other, and those come together in their pieces after you're through multiplying. Now, we can't add or combine these because they have different variables on them. But so this becomes our answer. Now, I hope if we look, we've given you a way to multiply and also a way to factor. And we'll talk more about it later. We're not going to worry about it too much right now. But I want anyone who is using algebra tiles for this purpose to kind of see what's happening. And so mine kind of shifted. But just like 3 times 4 equals 12 in our original little drawing, those are my factors, 3 times 4 equals 12. And so I could arrange these 12 tiles into a rectangle and I can find the 4 and the 3. Or I can start with the 3 and the 4 and find the 12. So today we started with these this area as a product, or the factors, and we made the rectangle. And it was real easy to see that everything in line with this is going to be one tall, one tall, one tall. Everything in this column is going to be x wide, everything in this one's going to be y wide, and this one's going to be 1 wide. I hope this helps. I know this can be tricky, but this is going to help an awful lot when we get to some other sections where we want to start talking about how to find the factors of this in other ways. And this is going to give us a model which is really going to be neat and make things just a lot easier than, for example, when I was in school and learning how to do the same thing. Anyway, I hope this helps you, and good luck with it and the homework.